Today's talk is about 5 practical things that you can do to secure information but probably aren't. Like Pat mentioned, the idea of the talk is that it is practical, technical things. We're not going to be talking about really exciting things like governance or policies or user education. So just to mention up front, in the talk, I may at some point mention companies that sell security things. It's a fact of life. We buy stuff from them. I don't get anything for it. So if anybody in the audience knows a tool that's better than the tool that I say, feel free to share it at the end. So the context of this is that about 5 years ago, I wrote a report for an organisation about the effectiveness of their information security controls that they put in. And they spent $11 million and 3 years establishing all of these controls. So what my report said was that basically the controls were as effective as this, and that it wasn't going to do what their organisation needed to do over the coming years. And so as you can imagine, the way management responded was just like this. They're like, wow, thank you so much, that's an amazing report. No. How management reported was like this. And yet you still believe me. There was no anger. The way they responded was like this. Full-blown crickets and tumbleweeds. They just ignored it. There was like, what? No, we didn't waste our money. And so when I realised that that was the case and that was the response, I thought to myself, right, there's obviously a fundamental disconnect here. And so I decided, look, I'm going to have to take a step back from what I've tried to explain to them, right? And look at actually what's the situation here? What are we trying to achieve? And what's the risk of that? And try and explain the risk to people. Because to all of us, right, the risks of what we're trying to do, what information security is incredibly obvious. And so one of the first things that I thought I'd have to try and explain to them is something that's basically obvious in Hollywood every day, which is a principle of risk that says past performance is not indicative of future performance. Or as they like to say in Hollywood, you're only as good as your last movie. And so to management, executive management, they have no concept that, oh, we've never been hacked before, therefore in the future that will never happen. That's how they think. And so what I started to try and explain to them is a little bit about the year 1697. Now 1697 was very, very important when it came to science, because at that point from all over Europe they sent an expedition. They got on a whole bunch of boats and they actually came out to what was then known as Terra Australis and Van Diemen's Land. They thought that was like one giant land mass or something, but it actually turned out that was Australia in 1697. They just hadn't mapped it yet. And so they came out here, and most of the scientists in that expedition were ornithologists, right? So they came to study birds. And the thing that was kind of crazy is in those days, if you said to a scientist in 1697, please describe for me what is a swan, you would categorically be given the answer, a swan is a beautiful white bird with an orange beak. And then they got off the boats in Australia and they saw this. And they were like, what the? Universe upside down. And so there's a very, very famous financial guy. His name's Nassim Nicholas Taleb. And he talks about a category of risk that he's called black swans, named after that black swan situation that the ornithologists realised when they came to Australia. And so Taleb quantifies a black swan risk event with 3 criteria. The first one is that it always comes as a surprise, right? People aren't sitting around going, oh yeah, we saw that coming. No, they never saw it coming, right? The second one is the impact is always catastrophic. And the third one is we had the data to avoid it actually happening, but we ignored it often more than once, right? Does this sound like information security to everybody? I think so. So I'll give you some examples that are easy to explain to management, right? They get this. So anybody who does handiwork outside of their job, might know what these are. These are O-rings. They're like little bits of plastic, and you put them for things like plumbing, to seal things together. So in 1986, there was an organisation who actually did a bunch of testing on O-rings. They did 24 tests, and they promptly ignored the risks of the results of 22 of those tests. So they had their sample size, they went, here's 24 tests, we'll exclude those 22 results, and we'll keep the 2 results that we liked. And then they launched a space shuttle, and that happened in front of hundreds of millions of people because the O-rings, right, the risk of those things just disintegrated as they took off. And so here's another one. Some of you may recognize this guy as a famous Hollywood actor. His name is James Woods. So James Woods was on a flight from Boston to Los Angeles, and he was flying in first class because, you know, he's an actor and that's what you do. And he was there with 5 guys, right? And he didn't like how these 5 guys were behaving. And so when the flight landed in Los Angeles, he actually went up to the cockpit door, knocked, they opened up, and he went into the co-pilot and the pilot, and he said, look, I was just in first class with these 5 guys. They're acting really weirdly. You need to call the FAA and the FBI and report these guys. There's just something fishy going on. So apparently the pilot and the co-pilot did just that. They reported it to the FAA and the FBI. The FBI promptly ignored it, and a week and a half later, 3 of the 5 guys slammed a plane into one of the World Trade Center buildings. The third one, probably not as exciting in terms of the graphical stuff we've got here, but this is a chart, a graph of the subprime lending in the United States from the years 1994 to 2006. So you can see it just gets completely out of control. 6 months after that, global financial crisis hits. So 3 criteria. Comes as a surprise, catastrophic impact, we had the data but didn't explain it properly and we ignored it. So to me at this point, I was like, okay, the rules of engagement of what I need to do now are pretty clear going forward. So basically what I was thinking is that I need to sit down and do a black box penetration test against the organisation, right? So how I would do that, I couldn't use any prior knowledge, right? It was like I was a complete outsider, wasn't allowed to use anything that I actually knew about the organisation internally. The attack would be based purely over the internet, okay? No access to anything that involved any sort of internal anything, right? My goal would be to actually do their worst nightmare. So get in and actually steal the stuff. I'm saying, here's the risk. This can happen. They're like, nah, we spend $11 million on 3 years, and in 3 years it can't happen, okay? So that's my goal. Get in and steal the stuff that they're scared of. And I could use any of the tools that I wanted at my disposal as long as I didn't use any corporate money. So if I wanted to do anything, I had to pay for it myself, right? So basically at this point, my primary concern is, okay, if I actually succeed, right, I need to protect the information that I'm going to steal, right? So I can't go off and steal all this kind of sensitive corporate stuff over the internet and risk something leaking. So I was like, okay, I need to design a piece of malware myself. I need to do it myself. I can't trust buying something off the shelf, even if it's something like Metasploit, I need to use it myself. So I went off and designed it. So before we get into the design of the malware and what I did, I'm going to talk to you about like what controls that these guys actually had in place, right? So you can see how closely it resembles the organizations that you guys work for. So they had all the usual suspects, right? They had antivirus, they had firewalls, they had intrusion detection, they had web content filtering, they had email content filtering. And just to make my life difficult, my boss called the information security team the day before I was going to attack them and said he's going to attack you tomorrow. Seems fair, right? So, most modern malware, right, has about 10 attributes that make up this. If you do one or more of these 10 things, that piece of software is now quantified as malware, okay? So I guess my general rule of thumb around this stuff is if it looks like a duck and it quacks like a duck, then it's a duck. So of those 5 things, I automatically chose to exclude 5 things to minimize the risk of what I was doing being detected as malware. So those 5 things that I chose to not implement in my design were armoring, which is basically the mechanism that malware uses to impede analysis. So if you get someone in there, they're trying to reverse engineer it, the malware actually does stuff in real time to get in your way. So I was like, no, I'm not going to do that, right? Metamorphism, right? So metamorphism is where malware recodes itself and it basically does that as it's spreading to avoid detection. So you've got one copy here, it's going to move laterally over there, and it goes, whoops, I'm going to change my code as I move. Metamorphism didn't do it, right? Polymorphism, right, is where you've got the malware running in memory, and as it's running in real time, it rewrites its own code to avoid detection. Again, clear indicative malware, didn't do it. Another one, propagation. My goal was to get in and steal information. It wasn't to own the entire network, and obviously there's dangers in doing that. So propagation was off the table, even though it was definitely possible. Self-defense, right? So basically the idea of self-defense is the malware's in, right? It's in, and then it's got a mechanism that it uses to actually inhibit removal once it's in. So I avoided that as well. So which 5 things did I focus on? So these are the 5. Command and control, big one for me, on the table, right? I wanted to deploy something and be able to control it remotely once it was on a box. Obfuscation, doing some very basic stuff in the guise of it looks like a duck and it quacks like a duck, so it's a duck. I basically wanted to deploy something and make it look like something else, because at a minimum, any malware is going to do that. Persistence, I wanted to get something on the box and keep it on the box, right? Once it's there, I wanted it to stay so that I could do stuff over a period of time. Payload separation, I wanted to build something, have one piece go in and have other pieces come in afterwards to segregate it out. Okay, and exfiltration, that was the big one, because of course the goal was to actually get stuff off of the network. So I was like, right, I need to make sure I design some really interesting exfiltration mechanisms there. So the malware itself was really, really simple, right? Designed to be really simple. Had a limited feature set, and basically the XML language that I designed had a number of features, right? And those were the following. I could create a variable in memory. I could generate a GUID and store it in a variable. I could generate an SHA-1 hash of a file or another variable and store it in a variable. I could download the content of a web page and store it in a variable. I could download a file and write it to disk. I could upload a file via HTTPS. I could decode and encode files using base64 and a couple of other encoding mechanisms. And I could execute code and funnel the output of that execution into a file on disk. So those are the basic features that I did. Now, with a little bit of sweet talking on my part, I got the malware deployed onto a target box and got a user to actually execute it. So now that we had that situation, I was like, right, this thing's on there, so how do we give this basic kind of bootstrap some serious teeth? So basically going back to the duck thing, right? Making it all very soft and fuzzy and simple and, you know, harmless. What I kind of thought to myself, what kind of tools could I use on an endpoint to achieve my goal that are guaranteed to not get detected, as malware, right? So it's either stuff that's built into Windows or literally freeware tools that I can pull off the net and run, that would be devastating. So here's the stuff that I ran that was built into Windows, right? So the first thing is grab a bunch of environment variables out of the box that I've landed on. So that tells me right off the bat who the user is, right, that's logged into the box, what's the domain they're on, what's the location of the system drive, i.e. C, and where is Windows installed. Then I basically find out all the IP addresses that are attached to the box, find out the full group policy for that user, write it to disk, find out a full list of services that are running on the box. Remember, this is all built into Windows, right? Just executing commands quietly. Finding out the password policy for the user that's logged in, getting a full list of all of the accounts and groups that are local on the box, finding out all of the drive letters that are mapped from that user, finding out every single process that's running in memory and all the DLLs that are attached to each executable, finding out what the trust zones are for Internet Explorer for the machine and for the user, and finding out whether auto run is enabled for that box especially for CDs and DVDs, because Windows has a different set of rules for USBs as it does to CDs and DVDs. So I got all this stuff, started gathering it up, and the next thing is, right, okay, great. Now I need to get this stuff back out the front door. How am I going to do that? So I download 7-zip, and that has two advantages. The first one is I get to compress everything in real time that I'm actually exfiltrating, and the second thing is I get AES 256 encryption for free, right? So start encrypting all this stuff that I've gathered up and start pushing it back out the front door, right, via HTTPS. So the next thing I do is download a scheduler and install that into Windows so that I can now execute my malware at specific predetermined times and start executing commands, right? And then I download a forensically sound deletion program so I can start cleaning up after myself and basically everything that I've downloaded, wipe it. So if by some miracle the information security guys realize what I've done and they go to actually forensically analyze anything, there's nothing left on the box, right? So basically now I've got a piece of malware, it's persistent, it's got a firmly established foothold on the network, and it's like, right, this is the fun bit, right? So what do we do next? I get a piece of freeware and execute it, and it gives me a list of every single piece of software on the box, including every version and like every patch version of each piece of software. A complete browser history for every browser that's on the box. A list of all the documents that the user's accessed in Windows. I query Active Directory as an authenticated user for everything. And I mean everything. Every single person that's ever worked in that organization, all 14,000 of them, all of their account details, the username, all their full email addresses, like every site that's on the network. There's home addresses in the site list of Active Directory of all the key executives. So I now know where all the key executives in the organization actually sleep at night. You can imagine how this went down, right? So one of my favorite things though was a freeware tool that I just ran. It's a command line thing, and it basically tells you every single file and directory on the network that that user has access to, permissions to, that they can read, right? So that's like, we got all that, and I again shove it back out the front door, and that's where it's at. And so in the interest of leaving no stone unturned, I actually wrote an add-on for Outlook that uses the Outlook API, and I basically queried Outlook seamlessly and extracted everything from Outlook. I mean everything. All the tasks, all the calendar items, all the email, everything, all the sent items, even the emails and the attachments that were in the PSTs. Boom, gone, out the front door, right? So I then took the browser history that I'd learned from the previous tool I'd ran, and I actually took all of that, and I didn't have to do anything special because all the sites internally all used pass-through authentication, and I just ran a replay attack. I just went through the list of all the URLs, found PDF files that sounded interesting, and just gave them to the browser and said, give me these files again and write them to this directory. Unauthenticated or pre-authenticated directly to all these sensitive apps. And then I chose from that file list of everything that I got, hundreds of sensitive files, like disturbing stuff, guys, really disturbing, and just pulled it off, encrypted it, and shoved it straight back out the front door, right? So that was pretty much the end. So an activity that took a lot of planning in terms of end-to-end, it took me about 3 months to plan, but only because I wanted to make sure that the information was secure. It took about 11 hours to execute for something that took 3 years to implement and $11 million to actually implement. So the question at this point is, why was that possible, right? It's not like they'd done nothing, right? They'd spent all this money, they had all these information security people, they'd done theoretically what you're supposed to do, right? Where did things go wrong? Like Indiana Jones in Raiders of the Lost Ark and the Nazis, they were all looking in the wrong place, right? Looking in the wrong place. The way most organizations still run their information security today is very much the castle and the moat model. And everyone in this room knows it. We're all like, oh, castle and moat, that doesn't work. But it's still the model that most of our organizations have. And so when you make the castle and moat thing work for your organization, this is basically how your controls end up looking. Complete Swiss cheese. And so because they don't account for the internet at all, it's like, oh, we've got castle and moat, but there's the internet, right? So The thing that I think is critical to actually understand at this point, before we go into talking about some technical controls and all the rest of it, is why does all that stuff break? Why is the castle and moat model broken? And it's pretty much because one idea in computing is very, very, very poorly communicated to executives and to the end users. And that's what I like to refer to as user context, right? So what people don't understand, right, is when they sit down in front of their computer and they're like, I've got a username, type. And they're like, I've now got this digital identity that's bound to me. What they don't understand is when they sit down and they're logged in and they've put in their password and it authenticates them, what their computer is actually doing is thousands of times a day as they're requesting resources across the network. I want an email, I want a list of my calendar items, I want a file from the file server, I want to go out the firewall, I want to browse the web. Every single time they do that, the network is actually speaking to their computer and re-authenticating them. They think the authentication bit is like when they type in their username and password. And what they don't understand is that when we say to them, don't click on something, it's bad, right? They think the reason we tell them that is because it'll like go and trash the network or their computer will be slow. They don't understand that when that piece of software runs on their box, that piece of software is them. Our malware is them. The network doesn't know that that piece of software isn't them asking for that file on that URL or that file on that file share or that email or sending that email or browsing the web. And when you start to explain it like that, the lights start to go on and they realize, oh my God, I'm accountable for that. Because if someone goes and checks the logs, nobody can tell the difference between the malware and me, right? And so I'll quickly talk about risk again. So when it comes to risk and how we try and mitigate these risks, what are the risks? What led to this compromise that I was able to achieve, right? So today, like information security is a little bit like driving a car, right? At some point, you're going to have an accident. And so how do you deal with the concept of how do we minimize that risk? How do we minimize the idea of something is going to go wrong? We need to minimize that as much as possible. So something really interesting, in Australia, since 1965, your chance of dying in a road fatality has dropped down by 90%. And the reason for that is we've actually implemented 5 different controls in cars, right? The first one was seatbelts. Boom, risk drops by 50%. Then we've got things like airbags, ABS, and a few other things. So I guess the point of this talk is this was all really straightforward. All of us know that that is something that is likely possible on networks that we either look after or people that we know. So what are the 5 things that we can start to do to stop that? Okay, so the first big vulnerability that we're exposed to in regular corporate networks, Windows networks, is arbitrary code execution. So what's that all about? Basically, we can run any code on any box most of the time. That's the first vulnerability. So lack of instrumentation of endpoints. That's the second thing. So we aren't correctly measuring the things that actually matter on our endpoint devices and even on the servers, right? So when the actual signs of compromise are just typically not things that we look for at all. The third thing is lack of application monitoring. So the actual applications themselves, the core information systems where the business relies on putting their sensitive information into, who can honestly say in the audience that you have a good understanding of even 1 or 2 core business applications and what regular use of that application looks like, right? And what the baseline is between that and anomalous behavior. The fourth one is something that has always broken my mind since I started working in IT, not even in information security. And that is that we, as a default, allow lateral movement on our networks. As a default. In the entire time I've been working in IT, I've never understood what the business reason is why one client PC on a local network should be allowed to talk to another client PC. I've never heard an actual business reason. Breaks my mind. And the last thing is the actual data that we're trying to protect. So the actual files, they themselves are not actually protected, okay? As a gross generalization. So let's talk about arbitrary code execution right up front. How are we going for time? Am I over? 5 minutes? Oh my God, okay. Okay, arbitrary code execution, I'll go quick. We'll save some time for questions, hopefully. Okay, so there's 2 prerequisites to do this thing in the way that I think works best. Feel free to prove me wrong. The first prerequisite is to make sure that the users don't have any administrative privilege on the desktop. That doesn't mean they can't get escalated privileges later on, but it means by default they don't have an administrative account. So you have to have regular users on the desktop. The second thing is you have to have encrypted hard drives on the endpoints. And I'll come back to why that is soon. Yeah. Okay. So what's application whitelisting, right? Application whitelisting is basically the opposite of antivirus. So antivirus is like, here's a big like blacklist of stuff, don't allow it. Application whitelisting is like, only allow this stuff, right? So how does it work? There's a couple of ways you can do it. The first way is here's a directory, only let stuff run from that directory. It's a lot of work. Second one is you can use digital signatures, right? So you can look at the digital signature of the exe and you can say only allow Adobe applications to run, or only Adobe Reader, or only Adobe Reader version 9.1. That's where we're aiming for, right? The third way is to use hashes, right? So it's possible all of you have heard this before. But one of the things that I learnt about, and when I talk about it with other information security people, some of them know about it, some of them don't, but there is actually a fourth way, and that way is only available through one vendor I know, and I'm not touting a vendor, but basically the way that it happens with this particular piece of software is it uses a thing called trusted ownership, which is essentially it uses the NTFS permissions on disk and checks if the executable is owned by the administrator. So let's think about that logically for a tick. You've got a user, right? We meet the 2 prerequisites. They're not an administrator and the hard drive is encrypted, right? They're using their browser, they get drive-by'd, right? An exe gets dropped on disk. The malware uses some sort of vulnerability to flick it and say, run, and that's it. It doesn't work. Because when it's written to disk as that user in that user's context, and the thing physically cannot execute. That's it, stopped by the kernel. How many of you would kill for that, that capability on your endpoint so you don't have to worry about, oh my God, the antivirus let it through. Now we've got to figure out, let's use FireEye to detect, oh, that looks a bit strange. No, there's an executable. It's not owned by the administrator on disk. It can't run. The end. So instrumenting endpoints is something that's kind of something that we don't do very well right now as a general rule, because what we're busy looking for on the endpoints is the first thing. We're trying to separate out all the signal and the noise. We're like, oh, there's this thing that's broken. We're trying to look for stuff that's coming through and getting through our AV and all the other controls we're trying to implement. How do we instrument it? So here's a couple of things, right, that we can actually do to separate the wheat from the chaff. Once we've got something like application whitelisting running on the endpoints and the servers, we can actually look for anomalous behavior. So if we know that all the time we're not trying to look for executables running, we've got that problem sorted out, we can go, oh, okay, here's this one really strange bit of behavior. Like, for example, someone trying to run an executable that they're not supposed to. Or someone that's running some of those inbuilt tools that I showed you before. Why is a regular user who spends 9/10 of their life in Word, Excel, PowerPoint, Outlook running command.exe? Why are they running ipconfig? Do we look for that now? Probably not. It's a good sign of compromise or attempted compromise. Authorized code running at really weird times. Most people work 9 to 5, 7 to 6 maybe, 7 to 7. Why is that desktop over there doing strange stuff at times at night when there's no human being sitting at the keyboard? So instrumentation. So in terms of the actual how do we monitor our applications? How do we get some insight into what those are doing? The first thing is developers, right? Sit with the developers. Once more for him, developers. Seriously, guys, how many of us have actually sat down with the developers and gone, right, can you please walk me through end to end on our most sensitive internal application? What does regular user traffic look like? What does a user look like when they use this app? Can they make 30 calls a second to the network? Probably not. How does that work? So we need to establish a baseline and work with the developers to understand it. Now, the best way to actually analyze this stuff with analysis tools is to get some really smart stuff that can do it. So we're looking for the anomalies, right, within application traffic. So, and application behavior, excuse me. So part of the problem is to do that stuff, the tools are really expensive. There's no doubt about that. But now, one of the things that's really awesome that is often viewed as like one of the great evils of information security, the cloud, this is where the cloud shines, right? We can take a whole bunch of log data that's related to applications. We can mask some of the data that's sensitive if we don't want it going up to the cloud, right? And we can do massive amounts of analysis using tools that are inexpensive, commoditized, off the shelf in the cloud to alert us in real time for anomalous behavior inside our applications, right? And if people are like, oh, that's too risky, well, what's the bigger risk? Like, end users doing something crazy with an application or a bad actor doing something crazy with an application and never knowing about it, or the business realizing that's a risk and signing off and saying, okay, that log data can go to the cloud. We're running out of time, so I might just very, very briefly go over the last two. I mentioned it before, lateral movement. So in terms of how do we stop lateral movement in a way that's not crazy? So there's two ways that I know of, like them or not. One of them is very specific to a Microsoft Windows environment. You can actually use IPsec from clients to servers to actually specify by Active Directory which users are actually allowed to talk to which machines on the network. I know it's Microsoft and all the rest of it, but it's here now, it actually works. Everybody's probably already licensed for it, that's one way. The other way is there are specialized kit, next generation firewalls that actually have the ability to talk to your directory services like Active Directory, and using an agent on the endpoint determine who the person is that's actually logged in at that IP address and determine what resources they're allowed access to on the network and block everything else. Not a bad way of stopping lateral movement. The last thing, which we don't have time for, is device control and rights management. But what I might quickly talk about is, can anyone have a guess at the stuff that we've talked about so far? So all the controls that I've just mentioned, right? Whitelisting, instrumenting the endpoints, blocking lateral movement, all of those things. What do those things have in common? Can anyone have a guess? Yep, they do. They do allow what should be allowed. Defining specifically, yep, that's it. But the key one, which most information security people don't think about, which I'm incredibly guilty of as well. Yeah, they're a combination of both. Sorry, I missed that. Got them, but you're not using them. But the key one, which is like blew my mind when I actually sat down and thought about it, is none of them, not a single one of them, affect the user experience. They're completely invisible to the end user. They wouldn't even know that you have those controls installed if you've done it right. If you've done it right, they should be able to do everything that the business requires them to do without getting stopped.